Okay, so I'm going to talk about, the technical talk is about using APIs in your workflows. We're talking about why you want to use an API in general, just to connect to your data. First, I wanted to start off with a definition of what so API stands for Application Programming Interface. Someone doesn't know. And this is the best definition I could find. I added the bold. So an API allows one piece of software to make use of the functionality of or data available to another. It provides a consistent programmatic method for accessing it. It's simply a structured way of exposing functionality. So the keys here is it's a structured way to expose your data to any application. So instead of trying to piecemeal, you're going to do this application, we need to access certain data, we'll figure out how to do that. You have a strategy to access your data in general, and then you can use that in all situations. And it allows you to create something for one application and then use it in another that you never considered up front without really making any changes. And preparing for this, I just kind of thought through, what exactly when I say API, what I'm talking about. So everything I'm going to show is going to be services that provide access to data and functionality. All my examples will be what you call RESTful. If anybody's sort of serious REST person that might disagree with me. Over HTTP, so over the internet. Those aren't the only kind of APIs that are available, but that's what I'm going to be talking about today. And I realized that all the APIs I'm going to show you, they return the response comes back in JavaScript object notation, the JSON format, which really a lot of the advantages I'm going to talk about are the JSON format itself, not so much the API. You could probably do similar things with XML, but I wouldn't want to try. Okay, so some of the benefits is that you can, like I said, you can access your data in a standard way from any application. So once up front, you got to decide how you're going to build the APIs, how you're going to access them. But once you have that in place, it makes building applications much, much easier because you don't really have to worry about the data. You know how you're going to access it. It enhances developer productivity if you use APIs internally, because a lot of things you're going to be using from third parties are going to be exposed that way. So once your people get used to work with APIs, using other people's is easier. And you can even make yours, you can make your responses, your software look like industry standard software. So at the end, I'll show you a little example of doing that. And it allows you to change things without breaking the application. So the only thing that's significant is how you communicate with the API. How it actually does its work doesn't matter. All that matters is that you can consistently send in a request and it will send back the same response you expect. As long as that happens, you can change how it works any way you want. And I thought one of the best way to try to show this is to go through a project that, it shows a lot of examples here. So this is the project's name is the Neotoma Paleoecology database. It's a database set up for researchers all over the world that are interested in, some people are pollen experts, some people are vertebrate experts, there's insect experts, and they'll find things in caves or cores in lakes or pack rat middens, and they'll see what lived here at a certain time. From that they can get environmental indicators, what it was like at that time. And for a long time, these were just mostly kept in Excel spreadsheets and individual researchers' computers, and they would, if you wanted to look at a certain area at a certain time, you'd have to know, well, who's the person that's responsible for this at this time. You'd have to get a hold of them. So they wanted to come up with a database where all the data could be pulled together. And the researchers wanted to be able to access the data. They didn't want to give up their data and then only be able to get it back in defined ways. They wanted to be able to still do anything they wanted with it. But they also wanted some shared applications that everyone could use, mostly to find the data, do a little bit of analysis, but mostly find it, download it, and then they can do whatever kind of analysis they want. One of the big advantages that I never even thought of until we started working on it was, and I'll show you a simple example of like an API response in a second, but it's basically just a string. So the string can be coming back from a server in real time in response to a request. You can also just type the string into your code while you're developing or write it to a file. So this really helped in the development. We would make little tiny applications and ask people what they wanted to be able to see, and we just hard-coded the responses in there. And then people would say, well, I'd like to see this or that, and we could just easily add it to the hard-coded, the hard-coded response. We didn't have to, do any programming really until we got it showing what everybody wanted, but then we knew what the API should provide, And then we only had to basically implement it once. We didn't have to keep, reprogramming as people wanted different things. And I'll try to show you an example of that too. It's the second one, the loading responses kind of fits into that same thing. You can load a response in real time from the API. You can also save it to your hard drive and load it later. Somebody asks a question about doing stuff in the field when you don't have a cell phone connection. You can cache that on the mobile device, go out and work on it. Since it's just a text string, really, the mobile device can manipulate it in the field, and then when you get back where you do have a connection, you can send the changes back to the server. And it's real flexible. Most things can connect over the web to an API, so you can use it with things you never intended up front. I'll talk about that in just a second here. So now we go to the demo. All right, so like I said, this project really, accessing the data is really the primary thing. Because people aren't going to give up their data and put it in here if they're not going to be able to use it. So we set up after we had it set up, we created a little developer center, we call it, so people could learn how to use it. Probably shouldn't go through that too much. Let me just show you a few examples of data, of API responses. So this lists all the taxa in the database. And I just want to show you this because there's two general kinds of responses. This one's basically just like tabular data. These are basically just a bunch of rows with 3 columns, taxa, name ID, and group ID, and they just get repeated over and over. So it's pretty much like a tabular data coming back from something like you might expect. This one is a little different. These are, all this information are found, they find things at specific sites, but then they break it up into what they call data sets. And you can have any number of data sets at a site. So this one shows you, you're coming down here, and it's all pretty much like a tabular response, and you get down to this data sets thing, and it's actually a collection of data sets. So this one site can have any number of data sets. If you're doing this more in a database, in the database world, you'd have like 2 tables here, and you'd have some kind of relationship between the two. From the site, you look up the data sets. But this way, you can just have it all, all in one response. You don't have to break it up like that. And I probably have never given this talk before. If I don't look at my notes, I'll skip a lot of stuff. All right, so let me show you so here's the application that then they use, like I said, mainly to find data and to basically explore the data set. And everything in here uses the API, so all the data in here, for instance, if I start typing the taxa name, it'll fill it in. So it loaded all those from the API. If I were to search on people, it loaded all those from the API. So every piece of information you see in here is coming from the API. So like a common search, I already forgot something. All right, so this is a search for all sites with the name Cottonwood in them. All right, and this is what you get back. And if we go in the interface and search for Cottonwood, so this very same string just came back, and then this mapped it. Okay, if you click on one, so this is the kind of stuff we mocked up beforehand and saw what people wanted. So, first we had a much simpler mock-up, and we'd have a test point, and you click on it, this thing would pop up, and it was just a hard-coded response, like I said, so people could say, oh, we need to add a description. You can have you could possibly have data sets that you didn't find in the search, but are really there. So we were able to flesh out exactly what people wanted to see, before we really did much programming. And the big payoff for that one was really in this form. So this is at that site for this data set. Up at the top here, this table is more like metadata. Every column here is a sample. So like this sample was found at 4 centimeters below the surface. It's estimated to be 193 years old by one technique, 199 by another. This is the next one down, another 4 centimeters down. So the sites go across the levels that they found. And then down at the bottom here, you can see all the different species and the counts that were found. So getting all this, you know, if we'd had to program this up front before showing it to anybody, we would have had a lot of iterations. But instead, we just kept showing this to people with the hard-coded responses. They would tell us what to add. The big one was, one of the big ones was this one. So there's one, you know, like people were talking about, you know, how should we label the axes? What units should we have on the axes? You know, should we show the points when you hover over a point? What should you show? So we were able to work all that out without really doing any programming at all. Well, no API programming. It's just totally the interface. All right, so once we got this developed, there was already it was an access. There was a small access database before, and a person had a front end they'd written in C++, which kind of made sure, like, if you're going to put a name of something in, that name isn't already in there. You know, everything's spelled the same. Made sure everything was consistent. And we were going to abandon that and come up with some kind of web front end. But once we got the API working, he was able to hook the C++ app up to the API, and so we didn't have to abandon it. He was able to modify what he already had to use the API to put the data in. And like I said, we never intended that up front, but because, you know, it's such a standardized way of communicating and pretty much everything can do it now, he was able to just add it to a C++ application. So when I was doing this, I originally thought people were going to build web apps like this with it. But yeah, so the C++ one was the first one. And actually the most popular one now, most of the younger researchers do their own, they do a lot of statistical analyses, and they use this package called R, if anybody's familiar with that. Kind of like SAS, it's been described to me, I don't really know R. But they were able to just use it, you know, with no modifications, spit out their statistics, even make maps and stuff in R, where before they had to gather up spreadsheets from people, get everything in the right format, you know, so it was consistent, then pull it into R. So this really made it a lot easier for them to do their analyses. Now there's one person that actually has it in Excel. They'll type coordinates into Excel, and they'll type a radius, and it'll bring back all the sites, yeah, within the radius into a spreadsheet, and then he can do whatever he wants to do in his spreadsheet. And I talked to him last week just to see if there's anything going on I didn't know about, and there is finally a group in Norway, I believe, that is putting their data into the database and then building their own web application, kind of what I thought people do at the beginning. But they're not going to use ours at all. So that, you know, they're putting their data in our standardized way, but they're going to build their own applications. It started out with 2 databases that committed to putting their data in, and there were 2 others that are on the fence. I think we're up to numbers 8 and 9 are coming in now, because once they realized they could still get to the data in any way they wanted to do whatever they want, they were all pretty happy about it, because they could, you know, combine with everybody else's data. They don't have to worry about storing backups, you know, anything like that. So it's really worked out well so far. Okay. All right, so then I wanted to show you this kind of, the next example will show you kind of what I'm saying about how you can change what you're doing, and it also just show you how you can think a little differently about stuff. All right, so the next couple examples will be implementing parts of ArcGIS Server. Esri released the ArcGIS Server API, as they call it, the GeoServices REST API. So you can, like I said, how things are done doesn't really matter. All that matters is you have a consistent way to send your requests and get back the responses. So in this case, this is for POSDA has they call it the Mine Maps Atlas, shows you where old underground mines are. They were getting these scans from DEP. So what DEP was providing were the scanned images, georeferenced, and an index shapefile with the bounding box of every map. And they wanted to be able to, well, this application had to use Esri's JavaScript API. That was another requirement. And we tried to figure out a way to do this with ArcGIS Server, but we couldn't figure out a way that would work, because there's thousands of these scans. If you would have done it that way, you'd have to have a map service with thousands of layers, which I'm not even sure would run. But even if it did, every time you would update it, you'd have to republish that thing with thousands of layers. And what they wanted was just to take the scans they're getting from DEP, drop them in a folder, and replace the index file. They wanted it to just be that simple. So since ArcGIS Server wouldn't do it, I basically implemented the GeoServices REST API. Let me show you that. So this is the application. These pinkish, or whatever those are, magenta, I guess. Those are the bounding boxes of the scans. So when you click on one, it finds all the bounding boxes that are at that location, and then you can see them all on this table here. But when you say View Map, it tells the server which image that the user just clicked on, and loads that into the map. So there's really only one layer on the map service on the back end, but it can on the fly load any one of thousands of scans. And they can just, like I said, DP gives them another shipment of scanned images. They can just drop them in the folder, replace the shapefile, and they're done. They don't have to update anything. Yeah. But you're communicating with it exactly like it's ArcGIS Server. It works in the Esri JavaScript API just like it's ArcGIS Server, because to the map it doesn't know that it isn't. There's absolutely no difference. Let's see. I had one. I just mentioned the one that I can't really show. It's behind firewalls. But I had another client that they needed to be able to let the user change the colors on the map. It also needed to work with Esri's JavaScript API, and they also needed the buffering and projection capabilities of the geometry service. So basically, we were able to do the same thing and just implement ArcGIS Server. Well, implement it so it appears to be ArcGIS Server, and you could do those things that ArcGIS Server doesn't really support. All right, and then the last thing, I did one thing just kind of for this presentation. So this one, again, it's an implementation of ArcGIS Server, but on the back end of this one is just a SQL Server database. And it's got the Surgo soils, the detailed soils for the whole state in it. And I had this demo in Crawford County, but last night at the hotel room I realized I should switch it to Washington County. I was able to find Washington County. They have their tax parcels on ArcGIS Online. So let me just show you first, then I'll do it. So you can click anywhere you want. Well, first I got to pick which layer. So there's the part. It just grabbed that parcel from ArcGIS Online from Washington County. And now if I hit the clip button, it just clipped the soils out of that statewide Surgo database I just told you about. The first time you do it, it takes a second. But after that, well, here, let me do a big one up here. So it's clipping, and that statewide soil database has 1.3 million polygons. And it just clipped it in, a tenth of a second or so. So you can do stuff that you wouldn't be able to do anything nearly that performant if it was truly in ArcGIS Server. And you couldn't clip either. ArcGIS Server can't clip. If you did this in ArcGIS Server, you'd have all those polygons going outside the boundaries of the parcel. So I was able to make an ArcGIS Server that actually does the clipping and does it much faster than the real one would. And it's just, like I said, the only thing behind it is just a standard SQL Server database for the soils, no special geo database or anything, just a straight SQL Server database. And so with stuff like this, you could give all your developers a ArcGIS Server Lite to play around with. You can install it on any number of servers that you want for real production stuff. If you need 80 or 90% of what ArcGIS Server does, buy ArcGIS Server. But if you only need half of it or so, you could take a route like this. And again, the reason this works is because it's just mimicking the API. It's just programming to the API. It doesn't matter how you do it. If it's ArcGIS Server doing it in the background, if it's SQL Server doing it in the background, if it's just, like I said, the scan geotips in the other one, it doesn't really matter because the API is the only thing you